So we're going to talk about trig review and the concept of being ready for calculus. And all these things should have been mastered. This is simply review and going through quickly some example problems to kind of help you prepare for math placement. We all know SOHCAHTOA. We've been doing it for quite a while. Sine, cosine, and tangent. I show a right triangle. We know that if we're going to apply sine, cosine, and tangent, it has to be a right triangle. Down below, you'll see law of sines, law of cosines. It does not have to be a right triangle. We also know that by drawing the triangle, which I show right here, that we can find these relationships right here. That sine of A is A over H, and so is cosine of B. And if you need to pause the video and go through these facts, do that now. Make sure you remember these things, because that is an important skill when you get to the placement. You have to slow down and think about those things so that we know. I found the one I want to go for first. So therefore, we can quickly see that sine A equals cosine B, sine B equals cosine A. Where A and B are complementary, where A and B sum to 90, that will always be true. Finally, we also know that if we take sine divided by cosine, B over H divided by A over H, we get D over A. Or over here, A over H divided by B over H, we get A over B. So tangent is sine over cosine. And those are three identities we got to be familiar with. Likewise, we can't lose the fact that we can also write the angle A as sine negative 1 of A over H of the ratio. So we got it two ways. We can either represent sine A as a ratio, or we can say A is the inverse sine of A over H. Likewise, for the placement test, you will have to have law of sines and law of cosines memorized. So even if you're just pumping and dumping for a couple days, you want to have these two. Law of sines we should know. Law of cosines sometimes gets confusing with time. We're going to do some examples here. But again, has to be a right triangle above this line, any triangle below the line. So law of sines and law of cosines can be on obtuse, it can be on acute, does not matter. It also works on a right triangle, but it is a waste of time. So let's do a couple examples. I got a red and blue one. Let triangle ABC be a right triangle with measurement of angle C being 90 degrees and sine of A being 3/7. Find cosine A, B, tangent B. All right, so we'll move the other problem down now. If you want to pause and try this, you should be able to do this problem. This is a good review problem. I'll just do a quick sketch. And it doesn't matter where A and B are. All right, and sine of A is 3/7. So the opposite of A is 3. The hypotenuse is 7. I can do Pythagorean theorem to find the other leg. I'm going to skip some steps here. We should all be comfortable if you take the time to do it. And again, if you're not comfortable with this, you're probably watching the wrong video. You're probably not ready for calculus. All right, so there's my triangle. Now I say find cosine A, B, and tangent B. All right, so cosine of A is the adjacent over the hypotenuse. So cosine A equals 2 square roots of 10 over 7. I'll do tangent B next because that's probably the easiest thing. Tangent B equals 2 square roots of 10 over 3. And I'm going to do B two ways. I'll do it in black. I can either write B equals tan negative 1 of 2 square roots of 10 over 3. That's the exact answer. That is the exact answer. Or I'm going to grab my calculator here. 2 times 10 square root. My calculator is old, divided by 3. I get 2.1. I got to take the inverse tangent of that. And if I round this to a tenth, I get 64.6 degrees. And if I want to make that into radians, we should all be familiar with that. How about, I'll go to one more decimal place for a rad. Now put radians, but it's unitless. So again, there's the answer for the red problem, and that's the way we work it. Again, exact answers versus decimal answers. Let tangent theta equal x, and find theta and cosine. Okay, so again, I'll draw a triangle. I'll put theta here. Tangent is opposite over adjacent. If it's just x, I see it as x over 1. All right. Now I'm going to have to do this in terms of x, obviously. So again, Pythagorean theorem here to find what I'll call h in black there. H squared equals x squared plus 1 squared. So h is going to be the square root of x squared plus 1 squared, which is just 1. So instead of calling it h, cross the h out, and I'll actually write it as x squared plus 1. So find theta and cosine theta. Cosine theta is probably the easiest. I can do cosine theta equals 1 over the square root of x squared plus 1. All right. Now we're not going to do this. We're going to have to rationalize this. So I'll do it in red. So I'll multiply top and bottom by the square root of x squared plus 1. 2 square roots make the whole. So I get a final answer of that. To find theta, there's a bunch of ways to do it. The easiest way for theta, I'll write it a bunch of ways. How about tan negative 1 of x? Or how about cosine negative 1 of x squared plus 1 over x squared plus 1? I suppose I could do the sine also. I'm not going to bother. But again, those should all be familiar, and those are all exact answers. All right, we'll keep on rolling here. Let's do a couple of law sines, law cosines. So here, and I'm not doing the triangle complete. If you can find one, you can find each. So I'll minimize the second one here. And again, you can practice this. These are both law sine problems. I'll move that down a little. So the top one here, I see. And you know it's a law of sine when you have 3 pieces of information and 2 of them are the leg and the angle. All right? And again, going back, the rule is sine A over A equals sine B over B equals sine C over C. So I can copy that. Let's take it up here. Put it on the board here for us. You know, you really should know this. It should be familiar. So it's find B. So this is pretty easy. I'm going to use A. So sine of 41 degrees over 10 equals sine of 77 degrees over B. And remember that the big letter indicates angle, the little letter across indicates the leg. So cross multiply and divide. And there's your exact answer. And again, if you want to get to a decimal, you just have to do the math. And if I do the math on my calculator here, I get 14.9 when I round, approximately, for the length of B. And again, find the length here. Now the other one here, again, it's a law of sines problem if I move down the page, because we see the 81 to 12, all right? And often we can see that C. So sine of C equal over 11, all right, because those are across, equals sine 81 over 12. I see that I can solve for sine C by multiplying both sides by 11. I'm going to take a second because a lot of times students get confused right here. If you just haven't done the practice or you get in a hurry, realize what I'm getting here. 11 times sine 81 divided by 12. It's a decimal, 0.9. And it better be because this is sine. It has to be between negative 1 and 1. When I go 4 decimal places. Guys, this is not the answer. We just found sine C. C is going to be the, we got to actually figure out that. All right, or C actually could be, I suppose, if we keep it exact, sine negative 1 of this stuff. Again, we should be familiar with all of these, but I'm going to use my calculator. I'm going to get a degree in a radian. I got degrees of 64.9 when I round degrees for C. Or again, I can multiply by pi and divide by 180, right, and make the conversion to radians. That should not be a surprise to us. And get 1.13 rads. Again, law of sines, right there. All right. Again, take the time to review it if you need to. All right. But again, you have to be able to do that on almost all placement tests for all colleges. Again, I'm going to copy it to the next one. The last one is a law of cosines. And you know it's a law of cosines when you have three pieces of information, but when you don't have an angle and a leg across from each other, then you're stuck with law of cosines. And again, I'm not going through the idea of that there's, you know, all the other possibilities. I mean, I could write them out, I suppose, real fast for you. I just do one general case, but there are all the other cases, and almost every textbook in the world lists them all. But if you've been in my class, you know how I talk about bookends. It matters that the leg and the angle are the opposites. So again, those are the other two. You can look at them. I'm going to erase them here, so I'm going to pause for a second, but they're going away. I'm just going to use the one. I don't want to memorize three things. I want to memorize one and understand it. So, law of cosines. Find ABC. I don't know if it's obtuse or acute. I don't. So I'll just draw the triangle, put A on it, put 60 on it, put B on it, put C on it. 20 is the length, 30 is the length. Immediately, you cannot use law of sine form. When you look at all the opposites, there is not a pair of numbers, so you are stuck in law of cosines. And if I see the angle 60, I'm going to jump for A here, all right, across. So I know those are my bookends. So I'll write A squared equals, and I'll put over here cosine of 60, because the leg and the angle have to be opposite sides of the formula. Now the other two legs just get plugged in. It doesn't matter where they fit. Now the math here is not hard, but often ends up in mistakes. Because what I see students invariably do here is this. They get here just beautifully. And everybody, I don't want to say the mistake. You can think of it. But they make a mistake on the next step. And the next step here is realizing these are not like terms. You cannot take 1300 minus 1. You cannot write 100 cosine 60. You have to do the multiplication. And if you do 1200 times cosine 60, you get 600. And now they're like terms. So 700 is A squared. I take the square root. I get A equals the square root of 700, which is 10 times the square root of 7. All right? And again, who knows how the answer is going to be? If you have to find multiple parts, that's fine. Or if you have to find a decimal, that's fine. All right? And now, don't do law of cosines again, because now you do have a sine angle. You have little a and capital A. All right. Last one for this review video, and again, we'll have a couple more in series and make a playlist, is one where you have law of cosines. And again, it doesn't matter where you label them. It just matters that you get it here. And again, you look at it, and it says find B. And I'll pull down my formula, so we have that. So again, you don't have, so you're gonna have to book it. And I'm looking for B, and I have the 3. So those are the first two things I'm gonna put in. 3 squared equals cosine of capital B. And then the 2 and the 4 just fill in. 2 squared plus 4 squared minus 2 times 2 times 4 cosine B. And again, we got to watch our math here. Often our mistakes here are simply in signs and multiplications, and too many students write at this point 4 cosine B on the right side. Guys, it's not 4 cosine B. They're not like terms, apples and oranges, cats and dogs. Don't let them breed. And watch your signs. So I get 11/16 equals cosine B when I solve the equation. Now, a couple ways to write this again. I'm going to go through all the ways to find an angle. First of all, B is going to equal then cosine of negative 1 11/16. That's the exact answer. I mean, that's as good an answer as you can get. Sometimes we want that. I'm going to give it as degrees again. I like degrees. About 46.6 when we round it. And if I want to make it to radians, I can do that. Times pi divided by 180. And usually I go 2 decimal places when I do a rad. I don't know why, I just do. About 0.18 radians. Everybody, these are the first few steps. These should be pretty well mastered at this. Here's the entire page snapshot. I'm going to go back and get the entire page of the other one also. All right, and finally I'll go to the entire page of the first one and the entire page of the review. Keep practicing, keep working.